Good morning. Myself Preeti Padarkar from the Jayawantrao Sawant Polytechnic, working as a lecturer in ENTC department. Today we are going to perform the experiment number 10 from the digital technique subject. The title of the experiment is build or a test function of SR flip-flop. SR flip-flop is nothing but a 1-bit memory cell. So we are using the SR flip-flop using NAND gate. The circuit is built SR flip-flop using NAND gate. So we required a 4 NAND gate, 1, 2 and 3 and 4. So first there are two inputs S and R, that is set and reset input, and two outputs Q and Q bar. So S input is given to one of the input of NAND gate, that is the first NAND gate. First and second input of NAND gate is connected together and given input S. Then output of this NAND gate is connected to third NAND gate, that is the pin number 3 is connected to pin number 10. Now the second input, that is the reset input, is given to the NAND gate 2, that is the 4 and 5 input is connected together and given R input to one of them. Then output of second NAND gate, that is the pin number 6, is connected to pin number 12, that is the fourth NAND gate, that is the input of pin number 12. So next is the pin number 9 is connected to pin number 11 and pin number 8 is connected to 13. This connection is a cross coupled connection. So 8 is the output terminal, that is the Q output, and 11th number pin is the output terminal, that is the Q bar terminal. So this is the circuit diagram of SR flip-flop using NAND gate. So for this circuit diagram, we show the truth table. There are two input S and R and two output Q and Q bar. When we give an input S and R equal to 0 and 0, that is a low input, so output is always the previous output. That is the Q and Q bar as it is we show, that is the same as previous output. The next input is 0 and when S is connected to 0 and R is connected to 1, the output is always reset output, that is called Q, that is the normal output is 0 and Q bar output is 1. So the normal output is 0, so this condition is called a reset condition. Then next input is S is 1 and R is 0. So Q is 1 and Q bar is 0. When Q is 1, so this condition is called set condition. The last is when S is 1 and R is 1, so both the inputs are 1 and 1. So this is called rest condition. Rest condition is nothing but both of the output is showing the output 1 and 1. And these two outputs are complement of each other. So this condition should be avoided. And these are the truth table of fourth condition of SR flip-flop 0, 0 to 1, 1. So this practical is a theoretical part. Now we see the demonstration of SR flip-flop on the digital trainer kit. Now we see the demonstration of SR flip-flop using NAND gate. So we required a NAND gate IC. So this is a NAND gate IC 7400. First, put this IC on a IC socket, fix this IC. We required a 4 NAND gate and one IC contain the 4 gate, first, second, third and fourth. First, we connect the VCC terminal, that is the pin number 14 to the plus 5 volt, and pin number 7 is connected to ground. Now we start with the connection. There are two input S and R and two output Q and Q bar. First, the pin number 1 and 2 is connected together. So pin number 1 and 2 connected together, and one of the input of pin number 1 and 2 is connected to input terminal. So one of the input is connected to input, that is the S input. Then pin number 3 of NAND gate is connected to pin number 10. So pin number 3 is connected to 10, that is the input of third NAND gate. Now the second input, that is the R input. So first pin number 4 and pin number 5 is connected together, and one of the input is connected to input terminal. So 4 and 5 connected together, and 5 number pin is connected to R terminal. So these are the two input S and R. Now the output terminal of pin second NAND gate, that is pin number 6, is connected to pin number 12. So pin number 6 is connected to 12, that is the input of fourth NAND gate. Now we cross couple the third and fourth NAND gate. So first the pin number 8 is connected to pin number 13. So 8 terminal is connected to 13, and 11 terminal is connected to 9 terminal. So 11 terminal, pin number 11 is connected to 9. This is called cross coupling of the gate. So pin number 8 is the output pin, first output, that is Q, and 11 number pin is the second output, Q bar. So this is the 8 number pin and this is the 11 number pin, Q and Q bar. In this way we're done with a SR gate using NAND gate connection. Now we see the observation table. So first turn on the power supply. So input is, first input is S is 0 and R is 0. So when we given S and R is equal to 0, 0, we show the output is previous output. So previous output is any 1, 0 or 0, 1. So this is the previous output. So this is called no change output. Next input is 0, 1, S is 0 and R is 1. So this is called a reset condition. So Q is 0 and Q bar is 1. So this is called a reset condition. Next, S is 1 and R is 0. S is 1 and R is 0. So the Q is 1 and Q bar is 0. This is called a set condition. Now we see the input is S is 1 and R is 1. Both the inputs are 1, 1 and both the outputs are also 1, 1. Q is 1 and Q bar is 1. So this output we see, this is a Q and this is a Q bar. So this should be complement of each other. So this output should be 0, 1 or 1, 0, but this showing the output is 1, 1. So this condition should be avoided. So we call this condition as a rest condition. So in this way we perform the SR flip-flop using NAND gate. Thank you.